All right, welcome back. So in this video, we're going to be a little bit more specific about the empirical problem that Clark and Cummins are trying to solve in this paper. That is why they believe that we should be measuring the persistence of social status more broadly, rather than the persistence of any specific manifestation like education and earnings, and why they think that their strategy for doing so is going to capture persistence and status. So to start with, I want to go back to the very first regression we thought about in this class, which is the intergenerational elasticity of earnings from Miles Korak. So you might remember the idea here is we want to know how parents' income affects children's income. So we might do something like log of EIT, where EIT is the earnings of a child in family I in generation T, equals alpha plus, I'll say alpha E plus beta E times EIT minus 1 plus error IT. So what this is saying, right, EIT minus 1 is the earnings of your parent, right, family I in generation T minus 1. EIT is the earnings of the child, right, family I in generation T. And so as we've talked about, right, if we've got a high amount of intergenerational mobility, that is if your parents' earnings don't matter that much for the child's earnings, we're going to end up with a low value of beta here. If we have a low amount of intergenerational mobility, we'll end up with a high beta here. And in relatively egalitarian societies, when we do this regression, we end up with a coefficient of beta somewhere around 1/3, right? In some societies, it can be as high as one half. In some, it can be as low as 1/5, right? In places like Scandinavia. And a coefficient around 1/3 is going to indicate that your parents' income might affect your income a lot, but your grandparents aren't going to affect you very much, and your great-grandparents are going to affect you even less, right? So let's say beta E is 1/3, right? That means that if your parent was 100% richer than my parent, richer. Here, I'll do it like this. Your parent was 100% richer, you would be 33% richer. Right? So if your grandparent was 100% richer, right? That would mean that your parent would be 33% richer, and you would be a third of 33% richer, so you would only be 11% richer. Right? So your grandparent has twice the money of my grandparent. You're going to only have about 10% more income than I will. Right? So still a meaningful amount, but not a dramatic difference. And your great-grandparent great-grandparent was 100% richer, right, then you would be a third of 11% richer, so you would be a little less than 4% richer. Right, so what this means is your great-grandparent could be twice as wealthy as my great-grandparent, and it would make an almost undetectable difference in your life, right? You and I would have very, very similar incomes. Your income would be estimated as just 4% higher than mine. And if we wanted to, we could go even a step further, right? Great-great-grandparent, it would be about 1%. Right? So anything beyond 3 generations is going to have essentially no detectable effect on your life. Now, the problem with this is that this doesn't match the reality that we observe very well, right? What this would suggest is that any sort of class system would essentially disappear very, very quickly unless you started out with incredibly extreme differences in wealth and income, right? It would suggest that we shouldn't see long-run legacy families. We shouldn't see long-term effects of wealth accumulation. The problem with this is the reason that this doesn't match reality is because this is assuming that your parent affects your income, but that your grandparent or great-grandparent or great-great-grandparent don't affect your income at all after we see your parents' income. In other words, if we're trying to guess how much you're going to earn, and we know how much your parent earned, it wouldn't help us at all to know how much your grandparent earned or how much your great-grandparent earned or how much your great-great-grandparent earned. And the problem with this is, if we do see all of this, in data where we do see all of this, that doesn't bear out. That doesn't match reality. In fact, if we know that your parent was wealthy, knowing that your grandparent was also wealthy is going to increase our guess of how much you're going to earn. In other words, let's say that instead of just regressing your earnings on your parents' earnings, we did something like log EIT equals alpha plus beta 1 log EIT minus 1, right? Beta 1 times the log of your parents' earnings plus beta 2 log EIT minus 2, right? Your grandparents' earnings, beta 3 EIT minus 3, right? Your great-grandparents' earnings, then plus an error term. We're going to end up, if we do this regression, getting positive values of beta 1 and beta 2 and even beta 3, right? Beta 2 will end up smaller than beta 1, beta 3 will be smaller than beta 2, but still, what this is going to suggest is, if I knew your parents' earnings, my guess for how much you'd earn would increase if I knew that your grandparent was also wealthy. It would increase if I knew that your great-grandparent was also wealthy. And this is going to explain why this finding we would expect from core X regressions, that anything beyond 2 generations doesn't really matter, might not actually hold. So, broadly speaking, there's 2 reasons that this can be true. So 2 reasons. Let's say beta 2 could be greater than 0. So the first reason is your grandparents might matter for you, right? They might affect your life directly. Right? So it could be that your parents are helping you most, right? They raise you, they're the most likely people to raise you. But grandparents interact with their grandchildren. They spend time with their grandchildren. They might donate money to their grandchildren's college funds or help out their children and thus their grandchildren when their children are low on money, right? So we might expect that essentially there's going to be a direct line between parent earnings and kid earnings, but there's also going to be a direct line between grandparent earnings and kid earnings. In other words, that the reason we might expect that having wealthier grandparents is going to help you is because those wealthier grandparents are literally actually helping you. Now, the problem with this is maybe plausible when we think about grandparents. It's not really plausible when we think about great-grandparents, right? Very few of us are going to be directly helped by our great-grandparents because for most of us, our great-grandparents aren't alive for most of our lives, right? So this might explain part of this, but it might not be a totally satisfying answer to all of this. So the other possibility is that grandparent earnings tell us more about your parents than just their earnings. So the idea here is, if I just look at parents' earnings and think about how that's going to affect children's well-being, we might expect that some parents earn a lot of money because they're really high-status people with lots of opportunities, right? We've got parents who went to super elite schools, got super elite jobs, and then earn super elite incomes. On the other hand, some parents might have relatively high earnings, not because they're super elite or super high status in other respects, but because in one way or another, they either got lucky or they made life decisions that prioritize their incomes. And that wouldn't matter if the thing that actually helps children is their parents' earnings, but it would matter if all of these other forms of advantage are also helping children. So a way to think about this, right, is let's say that we've got 2 families, both of whom have parents who collectively earn, say, $80,000 a year. In one family, parents collectively earn $80,000 a year because they've got difficult, dangerous jobs that pay hazard pay, something like working on an oil rig. and they work lots of overtime, right? So they end up with earnings that are way, way out of line, way, way beyond how high status we would expect them to be if we thought about their education or we thought about their family background, we thought about their vocabulary, all of these sorts of things, right? We've got people who have made decisions to maximize their earnings in ways that mean that their earnings are beyond what we might think of as their social status. And in the other family, we've got, elite college graduates who went to fancy private schools, went to prep school, have wealthy parents, all of this sort of stuff, but made decisions to be environmental activists or public defenders or something, artists and hippies. Made decisions that basically minimize their earnings potential, right? So maybe they're earning $80,000, and that's one of the lowest, by taking some of the lowest earning jobs or the lowest earning opportunities available to them given their family background. So if we take this literally, we think that it's just your parents' earnings that matter. We would expect that the children of oil rig workers would do just as well as the children of these prep school artists or activists, right? If we think that this broader set of things that determine social status matters, that things like knowing lots of people who are in elite institutions, or having a really large vocabulary, or having received a high level of education are going to affect your child, we would expect that the artists and hippies and public defenders would have children who do better than the children of oil rig workers on average. And so in that case, the reason that we would see higher earnings on average, right? We would guess higher about your earnings if we saw that your grandparents are wealthy or your great-grandparents are wealthy, isn't necessarily because your grandparents or great-grandparents are helping you, but rather because if you've got wealthy grandparents, that is going to increase our guess about how high status your parents were after we see their income. Right? If you have wealthy great-grandparents, that's going to increase our guess about how high status your parents were, even if we saw the wealth of your grandparents and your parents. In other words, someone earning $80,000 whose parents earn $200,000 is more likely to be higher status than someone who's earning $80,000 whose parents were earning $20,000. So Clark is going to take arguably the most extreme version of this hypothesis seriously. So he's going to say, essentially, there's a direct link between parent status to child status. And parent status is also going to affect parent earnings. Child status is going to directly affect child earnings. But there's no link between parent earnings and child earnings. In other words, given that you went to the fancy prep schools and you had wealthy parents and you got an elite education and you had all of these things that we associate with high status, it doesn't actually matter for your children at all, for your children's earnings at all, if you decided to take jobs as corporate lawyers or to take jobs as public defenders. All that matters is that parent status leads to child status. And as a result, if we look at grandparent status, this leads to parent status and to grandparent earnings. But none of this directly affects children at all. So in this model, the reason that we would see a relationship between grandparent earnings and child earnings is just because grandparent earnings are going to tell us something about parent status even after we see parents' earnings. Now, we can formalize this a little bit by thinking about this as two different regression equations. So we can say first, we've got an intergenerational equation, which is going to be, let's say, status IT. This is going to equal alpha status plus beta status and status IT minus 1 plus error. Right? So this is going to say we've got an intergenerational transmission of status that looks just like what we hypothesized before was our intergenerational transmission of earnings. And then we'll have an earnings equation where we'll say in a particular generation, our log earnings, IT, are going to equal, let's say, C plus D times status. And then we need some new kind of error term. Right? So essentially what this is saying is my status depends on my parent's status. My earnings depend on my status. But my earnings don't depend at all on my parent's status. Right? The only way that my parent affects me is by affecting my status through their status. So if this is what the real world looks like, these two equations here, what are we going to be doing? What are we really doing when we do the Korak regression, right? When we regress children's earnings onto parents' earnings. So what are we really doing when we say log of EIT equals, let's say, alpha E plus beta E times log EIT minus 1 plus error? Well, to think about this, we can think about what log earnings really is, right, as a function of status, and what your parents' log earnings really are as a function of status. So we can transform this equation into C plus D times SIT plus mu IT, right? This is just equal to log earnings, equals AE plus BE times log C plus D times SIT minus 1 plus mu I T minus 1 plus EIT. Right? And now we can do a little bit of rearranging here. So we can say SIT is going to equal AE minus, let's say, BE times, or sorry, AE minus C times 1 minus BE. We're just gathering together all of our constant terms, right? This is just constant, plus BE times this shouldn't be a log here, right? Because this is equal to log earnings. So just all that is equal to that. So then times D times SIT T minus 1 plus mu I T minus 1 plus EIT. Right? Minus mu IT. So we're basically going to have some new constant terms. Sorry, this was a little bit of a mess. But what we're basically doing is we're saying let's lump together all of our constant terms. Let's lump together all of our error terms. We're going to have some regression constant, some regression error, that's fine. And then we'll have beta here. What we're trying to estimate is going to be multiplied by D times SIT minus 1 plus mu IT minus 1. So if we were, sorry, this should be times D. So then if we divide everything by D, we're going to get SIT is going to equal some new constant plus beta E times SIT minus 1 plus mu IT over D. And then plus some error term. Right? So what's this going to mean? It's going to mean that when I look at the relationship between a child's earnings and a parent's earnings, this estimated intergenerational elasticity coefficient is basically going to be the average of the effect of the parent's status, which actually does affect children's earnings, right? Plus the effect of the randomness that determine the parent's earnings based on that parent's status. And the bigger this randomness is, that is, the less related parent status is to parent's earnings, the more we're going to underestimate this beta E, if we wanted beta E to be an estimate of beta S. Right, so what we're going to conclude from all of this is that beta E, the relationship between your earnings and your parents' earnings, is going to be less than beta S, the relationship between your status and your parent's status, because of the fact that we can think of your earnings as essentially mismeasuring your status as a result of this random component. The bigger that is, the bigger this difference is. So the way that Clark and Cummins deal with this, right, the strategy that they're going to use to solve this problem is essentially that they're going to say, what if we had a whole bunch of families that all had the same social status in period t minus 1, and we looked at how the average earnings of the parents in those families related to the average earnings of the children in those families. The reason that this might work, the reason we might be excited about this strategy, is that if we took the average of all of these different families' earnings, the average error term here would be about 0, right? If we average together a bunch of people, then any sort of error like this goes to 0. This is exactly the logic behind doing experiments. This is exactly the logic behind including larger and larger sample sizes. Right, so if we lump together a bunch of these families and we said what's the average of SIT, it would be constant plus beta E times the average of SIT minus 1, right, plus the average of mu I t minus 1 over D plus the average error. Right? And so this thing here gets closer and closer to 0 as we take the average of a larger and larger group of people. This thing here would get closer and closer to 0 if we lump together people totally randomly, but it's not going to get closer and closer to 0 if we lump together people who had relatively similar statuses, right? Or if we took a group of people that we believed all had high status. So there's a couple things to note here. The first is the way that Clark and Cummins are going to do this lumping together of a bunch of different families is by looking at families that have the same last name, right? So they're going to lump together families by their last name. The idea here is, right, if we've got all the people whose last names are Saybrook in one generation, all the people whose last names are Saybrook in the next generation, we're generally going to expect, because of the fact that last names are passed down from father to children, that everybody whose last name is Saybrook in generation T has a father whose last name was Saybrook in generation T minus 1. So this is a strategy that's going to let us compare the average earnings of a group of sons to the average earnings of those sons' fathers. Now, of course, this leaves out women completely, and this is sadly very common in a lot of social science research, and a lot of medical research, a lot of this stuff. So this is a really, really big caveat thrown on all of this, is that this is only a way to measure transmission of status from father to son. But given that, right, what we can argue is this is a way for us to follow groups of families across generations over potentially long time periods, right? As long as we're able to see what your last name is in a set of data, we can link you not to your particular parent, but to a group of parents that you probably belong to. Now, the other reason this is useful is because we can pick out families that have weird names, where those names have become associated over time for various reasons with either very high levels of status or very low levels of status. So if we start out with groups of names that we know are, associated with fabulous wealth, and we see that in 2 generations after we can assume that 2 generations after that fabulous wealth, people with that name likely have a high level of average status. And so as a result, the rate at which that status is going to regress to the mean is going to be a reasonable estimate of the actual transmission of status from father to child, right? The reason being that we're going to minimize this component, we're going to minimize the randomness associated with any particular family, and thus maximize the component that's due to the group of families as a whole having high levels of average status, right? So if we're able to lump together enough families and we're able to find large enough differences between the average status of a group of families and the average status overall, we're going to get closer and closer and closer to getting a BE that equals BS. Okay, so this is the basic idea. This is essentially what Clark and Cummins are going to do. And in the next video, I'm going to talk a little bit more specifically about the application of this strategy, right? The way that they use this with the data that they have, and then talk about their findings and what they do to interpret those findings.